solving equations with the variables on both sides. So we've done simple one-step, two-step equations, and we've used the distributive property. Now we're going to have to get variables from the left side to the right and right to left, back and forth. So our learning target is, how can I solve an equation that has a variable on both sides? What we need to understand is this identity, this idea of what is an identity. Well, I have an identity. I'm Mrs. Pridgeon. Some of you have an identity out there. It's your name. Your parents have an identity, right? Well, identity is who we are. Okay, if you're in my homeroom, you got to hear about purple people. If you're not in my homeroom, maybe you can ask one of your homeroom buddies. So a purple person has an identity. Well, in math, when you have an identity, that means it's true for all values. So an identity means an equation which basically has two equal sides. Okay, so our most obvious identity equation is x equals x. Okay, when you have x equals x, no matter what number you put into that left-hand side x, your right-hand side x is going to be the same. So if I put 5 here, I've got to use the same number there, 5. So 5 equals 5, that's always going to be the case. That makes an identity. Well, we can have identities which look a little bit different. Maybe I have 2x plus 1, and I'm going to want an equation that would equal the same thing. So if I did this, 2 times the quantity x plus 1/2, those two sides should always stay equal for no matter what number I put in for x. And some of you out there might be saying, why, how can that be? So if I were better at technology, I could have the Jeopardy song going in the background, and you could be pondering that over. But look and ask yourself, what is different about the left and the right side in that problem? What did she do, and how can she tell me that those are always going to be equal no matter what number she uses for the x or the y? Well, what do you notice if you were to distribute on the right-hand side? And remember, distribute means you multiply through the parentheses. So that means I would get that 2 times the x and 2 times 1/2. Wouldn't that convert right back to 2x plus 1? So the two sides are exactly the same, even though I tried to make that right-hand side look. So equations can sometimes work out and not be what we want them to be, okay? They come out and the answer just is kind of like, where did that come from? And some of us are thinking that all along because we're like, I don't know how I got that, but I did, and it kind of looks like it's not right. It doesn't make logical sense to me. But there are cases in everything in life in which some things are different than what we think, but they're actually correct. And in equations, we do have a couple of situations where we can have special solutions to the equation. So when we get an identity situation like that problem I showed you to begin with, we have two equal sides. Sorry, I'm trying to not block that camera, but I am. So two equal sides. And if I have two equal sides, that means that I get a situation where it says x equals x. And that says that any number I choose for x is a solution. And so any number works. And this is called all reals. And that means we have an infinite number of solutions for that problem. No matter what number we pick for x, we got to use the same number again. So we can do that forever and ever and ever, whether it's positive or negative. Then the next situation is we can get no solution. And this is really a tough one. And if an identity has two equal sides, no solution has a false statement that results. So usually what happens in this situation is that the variables disappear and we get two unequal numbers. So you work this out and you come out to get like 2 equals 3. And that's not possible. So we have a false statement, and that gives me no solution. Okay, no solution. It can't work. We're going to look at some examples. So I know I'm throwing a lot at you, but don't worry. We're going to put it to good practice. And the last one is what we're used to having happen, where we get one unique solution. Okay, so you work it out and it just solves. You get one answer for the variable. Okay, so like x equals 5. Nice. That's what we want. So the process that we have to go through again, remember, is that we're going to undo the order of operations. So the first thing we always have to do is kind of multitask here, is undo any parentheses and collect like terms. Now, keep in mind, sometimes you don't have parentheses, okay? So you might not have to undo the parentheses, but you may have to collect like terms, okay? Or you might undo the parentheses and there are no like terms. So sometimes not both of these things will be happening, okay? Then the big topic for today is when we have those variables on both sides. So we have to move all the variables to the same side. All right, we want to get all those x's either on the left or on the right. And remember, the key to success to make your life easy so you don't end up with a nasty negative that you have to divide by, and when we do inequalities, we don't like those at all, is we want to move the small to the big. So if you have 2 x's on the left and 3 x's on the right, you're moving your 2's to the right-hand side. If you have 3 on the left and 2 on the right, then the 2 is going to go to the left. And we usually like to have the x's on the left, but you're only going to do that if that's where the bigger amount is. So you got to get kind of ambidextrous in math and be able to go on both sides of the equal. Okay, then we follow our order of operations backwards. We undo our addition or subtraction, then undo multiplication or division. Okay, they're really mean to us, so put both in there. And that still just means that we're basically collecting like terms in step number 3, undoing addition and subtraction. Might be that we've got a couple of things being added together on the left side and a couple things being added together on the right side. Before we can get them undo addition and subtraction, we're going to have to collect those like terms maybe, which should have happened up above, but sometimes, you know, things happen and we got to do it more than once. Then the last part is we like to call the 3 S's. We have to simplify, solve, and check the solution, or solution check. Okay, so we're going to do all of that. It kind of all comes out in the wash or in the laundry, if you will, at that last process. Okay, so your last thing you're doing is getting X equals a number to be able to do in order to solve equations with variables that are on both sides. We have to be able to move the variables to the same side and then solve. Okay, we'll just do a little shorthand there. So solving is something most of us are pretty good at. Adding a variable on the extra side so that we've got a variable on both sides is a new thing. So we need to be able to remember that if we want to be successful at solving equations with have variables on both sides, the way we do that is by getting the variables on the same side and then working the equation out in the same process. Undo the parentheses, undo addition, subtraction, or multiplication and division, simplify, solve, and solution check.